Weathering, which begins the process, can be either mechanical or chemical. When rock undergoes mechanical weathering, such as frost wedging, it is broken into smaller and smaller pieces. Where steep, rocky slopes occur, frost wedging may generate large quantities of angular rock fragments that accumulate to produce talus slopes. Breaking a rock into smaller and smaller pieces increases the surface area available for chemical attack. Whereas mechanical weathering breaks rocks into smaller fragments without a change in composition, chemical weathering alters the chemical structure of minerals by removing and/or adding elements. One of the simplest types of chemical weathering occurs when a mineral dissolves in water. One of the most water-soluble minerals is halite, or common salt. Halite is composed of positively charged sodium ions and negatively charged chloride ions. Halite dissolves in water because the oxygen end of the water molecule has a slight negative charge, and the hydrogen ends are positively charged. When halite comes in contact with water, the negatively charged chloride ions are attracted to the positively charged hydrogen end of the water molecule, while the positively charged sodium ions are attracted to the negatively charged oxygen end of the water molecule. Once removed, these sodium and chloride ions are surrounded by water molecules, so they cannot rejoin the mineral structure. Thus we say halite has been dissolved by water. Many other chemical reactions break down rocks by disrupting the chemical structure. For example, carbonic acid forms when rain dissolves carbon dioxide as it falls through the atmosphere. Although carbonic acid is very weak, it reacts with minerals like stronger acids, but at a much slower rate. Let's see how carbonic acid reacts with the common igneous rock, granite. This weak acid slowly reacts with potassium feldspar to produce insoluble clay minerals, plus ions of potassium and silica dissolved in water. These clay minerals are often carried to a body of water where they eventually become the sedimentary rock, shale. The potassium and silica that was dissolved in water will eventually form other sedimentary rocks. Quartz, the other main component of granite, is very resistant to chemical weathering. Hence, with the breakdown of feldspar, quartz grains are released. These resistant grains may accumulate as dunes, beaches, or other sandy deposits. To summarize, the chemical weathering of granite produces clay minerals along with potassium ions and silica, which enters into solution. In addition, durable quartz grains are freed. Erosional agents such as running water, wind, waves, and ice remove the products of weathering and transport them to other locations. Eventually, these solid particles and dissolved substances called sediment are deposited. Next, the sediments undergo lithification, meaning conversion to rock, either by compaction or by cementation, as percolating water coats the sediment with mineral matter and gradually cements the particles together. The result is sedimentary rocks, such as shale, sandstone, and conglomerate. Some sedimentary rocks are not compacted or cemented, but form as solid masses of intergrown crystals. Rock salt is one example. Another word for cementation and compaction is frost wedging is a form of an accumulation of angular rock fragments at the base of a cliff produced by mechanical weathering processes is called a to increase the effects of chemical weathering on a rock, it would be useful to the surface area of the rock. Chemical weathering alters the chemical structure of a mineral by
Which one do you guys think it is? You think C? A? Who thinks it's A?
in a water molecule, the hydrogen ends have a electrical charge.
No.
When rain dissolves carbon dioxide in the air, it forms a weak acid known as which of the following minerals is very resistant to chemical weathering? Sand, or quartz grains, is a product of the weathering of which of the following minerals is most soluble? Which of the following is not one of the main products of weathering?